Once Einstein declared that the speed of light is the same for all observers, the universe had to reorganize itself around this law. The implications were profound, forcing time and space to behave in ways that defied centuries of intuition. The first consequence was time dilation. A moving clock does not tick at the same rate as a stationary one. To an observer watching from the ground, the faster a clock travels, the slower it runs. This is not an illusion of perception, but a measurable fact. At near light speeds, time itself stretches, expanding the duration between ticks of the clock. Equally astonishing was the discovery of length contraction. An object in motion is shortened along the direction of its travel, as if compressed by its own velocity. A spaceship racing close to the speed of light will appear, to an outside observer, to shrink in length. To those on board, nothing has changed. Their ship feels the same, their rulers unchanged. Yet to others, the universe insists on the contraction. These effects are not mere curiosities. They are confirmed by experiments. In particle accelerators, unstable particles such as muons survive longer than they should, their decays slowed by the time dilation of their rapid motion. Satellites in orbit, like those that form the GPS network, experience both gravitational and relativistic effects. Without correcting for time dilation, your smartphone's location would drift kilometers off course within hours. The twin paradox illustrates these consequences vividly. Imagine two siblings. One stays on Earth while the other travels in a near-light-speed spacecraft. When the traveler returns, she is younger than her sibling, not by minutes, but by years. Their lives diverge not because of biological differences, but because they have taken different paths through space-time. These results, once shocking, are now the foundation of modern technology and cosmology. Time dilation and length contraction are not exotic. They are woven into the fabric of reality. They remind us that human intuition, shaped by everyday speeds and scales, is only a limited guide. At high velocities, the universe reveals its deeper laws that appear strange, but are consistent, precise, and universal. Einstein's revolution was not only about equations, it was about changing the meaning of time and space themselves. What had once seemed absolute turned out to be conditional. What had once felt stable proved elastic. The constancy of light required sacrifices, and, in return, it gave us a universe far more wondrous than the one we had imagined.